Every aligned model you have ever talked to was shaped, in the end, by a pile of human opinions. Somewhere, real people sat down, read pairs of answers, and clicked which one was better. That quiet pile of clicks is human preference data, and it is the raw material that turns a capable model into a helpful one. But here is the uncomfortable part. That data carries every bias and blind spot of the people who made it, and no clever algorithm downstream can fully undo bad judgments baked in at the source. Let's unpack it. So why collect opinions at all instead of just writing down what a good answer looks like? Here's the contrast side by side. Writing explicit rules for what makes an answer good sounds tempting, until you actually try. What counts as helpful, honest, or safe shifts with every prompt, every user, and every context. There is no formula, no loss function you can write down for a genuinely good response, which is exactly why the rulebook approach collapses the moment real questions arrive. Teams have tried, and the guidelines just balloon into hundreds of pages while still missing the cases that actually matter. Human preference data takes the opposite route. You show people two candidate responses to the same prompt and simply ask which one is better. People struggle to define good in the abstract, but they are remarkably reliable at comparing two concrete answers, and that relative judgment is something a model can actually learn from its scale. At its core, gathering this data is a loop, repeated over and over at scale. Follow it one stage at a time. Start at the beginning. Take a single prompt and have the model generate two or more candidate responses to it. These are the raw material, several different attempts at answering the same question, and none of them yet labeled good or bad. Now bring in a person. A human labeler reads the candidates and picks the one that is better, more helpful, more accurate, safer, sometimes even rating how much better or ranking several at once. That single choice is one preference comparison. Then repeat again and again. Do this across many thousands of prompts with many different labelers, and you accumulate a large dataset of comparisons, each one a small human verdict about which response people actually prefer. The bigger and more careful that dataset, the stronger the signal you can train on. Finally, put it to work. Those collected comparisons are exactly what trains the reward model in RLHF, or feeds a method like DPO directly. The people's judgments become the signal the whole alignment process optimizes toward. Strip it all back, and three ideas capture why this data matters so much. At bottom, this is just human judgment made concrete. Rather than a score handed down by a formula, it is real people saying, between these two answers, this one is better. That comparison is the atom everything else is built from. It is the fuel every alignment method runs on. RLHF, DPO, and their many cousins all learn from exactly this data. Change the method and the recipe shifts, but the underlying ingredient, human preferences, stays the same across all of them. Improve the data itself, and every method downstream quietly improves with it. And it quietly sets a ceiling on quality. The data inherits its labeler's biases, a pull toward longer, more confident-sounding answers, disagreements between raters, and gaps where they simply lack expertise. Biased preferences produce a biased reward model, and no downstream trick fully repairs bad data. Alright, let's lock in what matters. Human preference data is the collected human judgments of which model response is better, gathered by having people compare candidate answers. It is the raw material behind alignment, the data that trains the reward model in RLHF and feeds direct methods like DPO. Because it encodes fuzzy human values no rule could specify, its scale and quality directly shape how good the aligned model becomes. But it also carries labeler biases and inconsistencies that quietly cap alignment, which is why so much effort goes into guidelines, quality control, and AI-generated preferences. Want more AI ideas unpacked without the jargon? That's exactly what we do over at standarity.com. See you there.